We will begin this week with a homework review, and on your homework paper you were to use string or pipe cleaners to represent wire and the pictures to cut out and put together to make a circuit. Or if you had real materials, I wanted you to go ahead and build an open circuit and a closed circuit. In at least one of these two circuits, I wanted to see you include a switch. So whether you did them with the pictures and string or whether you had the materials to build them, let's go over some of the options you may have sent me. So let's take a look at this. Here's an open circuit. This is built with real materials. You can see that the red wire is connected from the battery terminal to the light bulb terminal. Another red wire goes from the light bulb terminal to the switch, and a black wire goes from the switch to the other side of the double battery terminal. However, this is an open circuit because the switch in this picture is open. So that is why the light bulb in this picture is not lit. Alright, let's take a look at another one. This is another example of an open circuit. Here you see we are just using one of the battery terminals, and the red wire is going from the battery terminal to the light bulb terminal, and the black wire is going from the battery terminal, but it is not connected. You can see it laying off to the side there. So this is an open circuit because the electricity cannot make a complete loop. Without that black wire connected into the terminal properly, the electricity won't flow. So this is another example of an open circuit that you may have built. Okay, let's look at the next one. Let's look at some closed circuits. Here you can see that this is a closed circuit because the light bulb in the picture is lit. The red wire connects from the battery terminal to the light bulb terminal. The black wire goes from the light bulb terminal back to the battery terminal, so everything is connected and electricity is making a nice loop there. So this is a closed circuit and the light bulb is lit. And let's look at another example. Here you can see we're using a double battery terminal, and the wire on the bottom of the picture is going from the battery terminal to the light bulb. Then we have another red wire that's going from the light bulb terminal to the switch, and we have a black wire going from the switch back to the other side of the double battery or the double cell. A lot of times battery terminals are called cells. So we can see here that the light bulb is lit and the switch in this case is closed, so that allows the electricity to flow through that switch and make a complete loop. So this is an example of a closed circuit with a switch. Now I want to show you some examples if you did this with the symbol, or not symbols, but pictures that were on the paper. You could have a light bulb with a battery and two strings and one string not touching the light bulb. This would be an open circuit. Here is another example of an open circuit because the switch is open. You can see that the string is going from the bottom of the battery to the side of the light bulb, from the bottom of the light bulb to the switch, and from the other side of the switch back to the battery, but because that switch is open, the electricity will not flow. So this is another example of an open circuit with a switch. Here we have a closed circuit. It's very important to note when you're doing something like this that the black line that's representing the wire, one of them is going to the side of the light bulb, the bottom of the light bulb there, the side part, and the other one is coming from the bottom of the light bulb. If you do not have a light bulb terminal, those are the two locations that the wire needs to connect. So, and obviously the wire needs to connect on both ends of the battery. This again is a picture of a closed circuit. And here we have a closed circuit with a switch. So our wire on the bottom is going from the battery to the side of the light bulb bottom, and then we have a wire going from the very bottom to the switch, and a wire going from the switch to the top of the battery. And since the switch is closed, then the light bulb will light. So this again is a closed circuit. So those are some examples of open and closed circuits that you could have turned in for your homework this week. Let's take a look at this homework sheet. We have the symbol for open circuit there. We have the symbol for the light bulb. We have a symbol for motor. We have the symbol for fuse. We have the symbol for a terminal. We have the symbol for a wire, and the symbol for a battery, and a symbol for a closed circuit. You were, after completing your circuits with your real materials or pictures of real materials, on this page you were to build the same circuits with symbols. So let's take a look at this first one. This first one is an open circuit with a switch. You can see the battery, or what's often called a cell, on the bottom, the light bulb on the right side, and the open circuit is on the top. So this light bulb will not light because the circuit is open. Here's another example of an open circuit without a switch. Here we just have wires going, but you can see there on the bottom left that the wires do not touch. So this light bulb will not light as well. This is also an open circuit. This is a closed circuit with a closed switch. Here you can see that the closed switch allows electricity to flow the whole way around and go from the battery the whole way through the switch to the light bulb and back again to the battery. This is a closed circuit, and this light bulb would light. Here's an example of a closed circuit without a switch. In this case, the wire flows to one side of the light bulb and goes from the bottom of the light bulb on back to the battery. This light bulb would also light. This is also a closed circuit. So these are some examples of what you may have drawn for your homework, for your circuit symbol homework. Let's now take a look at the discussion questions. This past week, your discussion question, the first one was open and closed circuits and switches. The question read, describe the difference between an open circuit and a closed circuit. Also name two examples of switches that you use daily other than light switches. An open circuit has a place where wires are not connected, or a switch opens the path so electricity cannot make a complete loop. In a closed circuit, all connections are made and switches are closed so that electricity can make a complete loop. That is the difference between an open circuit and a closed circuit. Examples of switches that you may have used are a car radio, a computer on button, a curling iron, a hair dryer, if you have a fan, numerous things, anything that uses electricity would work for an example here. Okay, let's look at the second discussion question. Two types of electricity. Explain why short circuits I have the wrong title on this one. Discussion question 2 was short circuits. Explain why short circuits can be dangerous and two things that prevent short circuits from causing damage. So the title of discussion question 2 was actually short circuits. And two things that prevent short circuits are fuses and circuit breakers. Short circuits can be dangerous because they cause a great amount of heat since there is no resistance from something like a light bulb or a motor. Short circuits can cause things to melt or even catch fire. So that is what makes short circuits dangerous. So these are some examples of what you could have written for your discussion questions. If you have any questions about these, just let me know, and let's head. We're going to head into our student notes in the next video, and then in the third video this week we are going to be doing our experiment. So our experiment this week will be on conductors and insulators. If you have any questions about the past homework, be sure to let me know.